I want to take a look at this pushHead function and explain the logic behind it. Here to the right, I have our main function. And so starting with creating a pointer variable head, which points to null currently, and then calling the pushHead function and inserting elements or nodes at the beginning of our list as we create our list. So on the right hand side, this white canvas is a representation of our memory frame. And then the top part is the heap and the bottom part is the stack. So when we call the main function, a stack frame is created or an activation record is created in the stack frame. And inside our main function, we have one variable, and that variable is our head pointer. And the head pointer, this is pointing to null currently. So I'll just do it right here. It's pointing to null. After this line, we call our pushHead function. And when we call our pushHead function, an activation record is created. And inside our pushHead, we have several pointer variables. The first one is our double pointer head, and then we have our new node, then we have our head pointer variable. So on lines 32, where it says new node, we allocate memory to create a node in the heap using the malloc function. This particular node has an address, and new node is holding that address. So when we go to our first call, this head is assigned the address of this head. And the data that we're entering is 5. So that's what line 38 does. And on line 39, we set the next part to equal null. And in this case, at the moment, our head is pointing to null. And if that's the case, then we want our head to equal to the new node. So this head is basically holding the address of this head, which is essentially this head. So they're aliases for each other. So what's happening in line 41 is if head is null, which it is, based on this memory address, we're going to have head point to this new node that we created. So now head holds the address of this new node, and head is now an alias for this new node. And so the else part we skip because we don't have any other nodes on the list, and we started as an empty list. And so what happens is now we have 5 inserted, and after we execute this function, which we've completed because we're not going to even go into this else condition, this function is popped off. So this is popped off. And then we go ahead and call pushHead again, and so a new activation record is created while this is popped off. And what's happening here is now we pass on the address of this head, and we want to insert the data 10. And so we go here and we create a new node. And so our new node is created, and then we insert the data 10, and this is currently pointing to null. Then we get to this condition, is head equal null? Well, let's take a look at our head. No, it's not equal null because it's pointing to the previous node that we created. So we go here on lines 45, and then we jump to 47. If it doesn't equal null and we do not have an empty list, what we want to do is the new node's next, which is this right here, we want to assign head to that. And so right now head, this is head right here. So we're going to assign head to that. So this is what our pictorial representation looks like right now. And then, but here's the problem. Our head is always supposed to be the first node, and right now it's pointing to the second node. So we have to change this, or we have to change where the head is pointing and point it to the first node, because right now this is our new node. This is where our new node is pointing. And so we want to assign the address of new node to head. So now we have head pointing to the very first node of the list, and it's now pointing to the previous node that we created. We complete this function, and again, this is popped off. This is popped off, this whole thing, and we go back to main. And then once we go back to main, we call the pushHead function again. And since we have the same variables, technically I should be erasing all of this and just popping it off, but since we have the same variables, this is a new call for pushHead. So now what we're doing is we're calling the address of head again, and we're putting it inside of this parameter, and it essentially becomes this head once we get down here. So what we're doing now is we go to line 32 again, and we're going to create a new node, and we're going to use malloc function to create a node in the heap. So I'm going to put it right here, and this new node is pointing to the address of that. And then we go to line 38, and we enter the data, which will be a 15. And then we go to 41. Is our head null? Well, no, head is pointing to the first element. So let's just say, let me create an address. Let's just say that this is 0x100, and this is 0x200. So this is pointing to 0x100. So right now, head has an address of 0x200. So we go to our else statement. And what we want to do is we want our new node, the next portion, we want the next portion of it, we want to assign the head to it. So this head, where our head is pointing, so this will now point here. So this will become 0x200, holding this address. And so now again, this becomes our first node of our list, but our head is currently pointing to our second node, so we have to change that. So we have to assign new node to head, just like that. We exit out of this function, and this is popped off. So I'll go ahead and pop it off. And we are left with a linked list of 15, 10, and 5. The output, once we print it out using the print list head function, the output will be 15, 10, and 5. And then we return 0, and main is popped off the stack frame. In terms of time complexity, if you look at this function, we don't have any for loops or while loops, and we're not traversing any part of the elements of the node. So we're not traversing each node of the list. All we're doing is simply adding at the beginning or at the head of the list. And so the time complexity is O of 1. It's constant. Now I want to talk about our error check, 33 to 37. What can cause memory to not be allocated? Well, if you look at this currently, once our pushHead functions are popped off the stack, these nodes, or the memory that we allocated for these nodes, are still in the heap because C does not have an automatic garbage collection. We have to delete each of these nodes manually. So later on, I am going to create a function which will delete each node and clear our heap memory. So what happens is, if our heap runs out of memory because we just never clean up all of these nodes, say we create 1 million or 1 billion of these nodes and our heap is we just have a heap overflow, a new node cannot be created, so our new node will equal null, and this print message will print, and then we'll immediately exit out of our function. And so this is an explanation, or a short explanation, of how the pushHead function works, the logic of it, why it's important to clean up our garbage or the memory that we created in the heap, why it's important to free those.